Thanks again for joining us today as we talk about the anatomy of observability. My name is Kelly Bakelich. I'll be your host for today. Before we get started, just want to cover a couple of housekeeping items. First off, we will have a Q&A session with our speaker at the end of the presentation. So if you're new to Zoom and would like to ask a question, just feel free to use the chat feature at the bottom of your screen, and I'll add it to our queue. Second, we are recording today's session and we will send you a copy either later today or early tomorrow. So feel free to revisit this and share with your friends and colleagues. And lastly, if you are experiencing any technical issues, again, just feel free to use that chat feature and I'll assist you as soon as possible. All right, now the fun begins. I am very excited to introduce today's speaker, Carl Brahms. Carl is on the customer success team at Lightstep, where he helps people reduce the impact of change. He has spent most of his career focused on tools and techniques to make distributed systems more visible, and feels the world would run much better if we took the time to properly instrument it. And I also will say Carl has the best hats. So with that, I give you Carl.
Thanks, Kelly. So yeah, just to kind of touch on a little bit about my background, so you know where I'm coming from. As Kelly said, I'm a technical account manager at Lightstep on the customer success side. But by the age of 10, I had built my first PC. And by the time I was 20, I think I was more proficient in reading Apache web server logs than English, and English is my first language. But so I've worn a lot of hats. I was a Unix sysadmin. I worked on everything from storage arrays to data centers. I rolled out distributed tracing, cloud monitoring with tools like AppD and Datadog. And I've been really lucky to work with on some cool projects, really cool things, and with a lot of smart people. I thought I would have a bright career building pretty dashboards and alerts, but then cloud happened. And I think I've spent about like the last 5 years unlearning the previous 15. But so enough about me. Today, I want to share what I wish I knew a few years ago when we were starting to migrate to hybrid cloud and dealing with everything that comes with it. We're going to talk about some problems that observability can and can't help you with. And the most important insight that you're going to take away with you today is that observability works best when it's designed to help you understand change. So normally when you hear someone talk about having observability, it looks like this. They're collecting a bunch of measurements about what's happening in your system. And these are usually represented as metrics, and traces, and logs or events. And but it can be thought of as information about two things: resources and transactions. Transactions are the things that traverse your system and hopefully do something. And these could represent actions in like a mobile app or database call, invoking like a function or so on. And then resources. Resources are the things that you're in your system that your transactions consume in order to do their work. So the important thing to remember here is that transactions and resources are related because transactions consume resources. So normally we store metrics in purpose-built storage, like a time series database for metrics, along with metadata. And metadata is like tags or attributes about the telemetry. These metrics feed up to a front end that gives you dashboards and charts and alerts. Alongside that, you're pulling in events and logs into some kind of interface that lets you query and group the logs, run analytics, view transactions, sort by duration or error rate. And then finally, you may have a UI that's pulling these things together on a single page, and that lets you filter each telemetry interface by a service name or operation name, etc. And when vendors talk about being able to correlate your data, they mean you can query each data store for telemetry containing your search string, usually by some common tag. But really, we're still just looking at kind of a bunch of telemetry. It's still telemetry, and you don't really have observability. So if observability isn't the telemetry, it isn't storing and presenting that telemetry, then what is it? Observability is whatever helps you understand one fundamental question about your system. What caused that change? Change is the inevitable constant in a distributed system, whether it's planned or unplanned. This could be a change in traffic patterns or performance. Something is always changing. It's a fun fact that 70% or more of production incidents are caused by intentional software changes. Plan changes and workflows can change, and customers adopt your services. You may have a sale, peak utilization. There's hidden dependencies in your cloud infrastructure. These changes happen more and more frequently, and this question just becomes a lot harder to answer. And so by the end of the day, observability is really about two types of change: facilitating intentional change around deployments, and then mitigating unintentional change. In both cases, change is at the center of problems that observability is trying to solve. So it needs to really be one of the core competencies of a system if it's going to provide you with any value. If you have any amount of complexity in your system, you know it's super easy to get pulled into rabbit holes when you're troubleshooting. It's easy to find worrisome symptoms, like you have alerts coming all day to tell you those, but it's difficult or impossible to determine what changes led to those symptoms. Organizations are drowning in data because we typically only build dashboards that show symptoms of a problem, and they rarely are able to show us what's actually changed. And then as your architecture continues to grow, it's harder to differentiate good changes from bad changes. And we start losing confidence in our ability to respond to change effectively at all. So how do we solve this? Well, we think if you just add a little more context, it'll finally be enough, right? Like, you may have an epiphany and, start making, things will just start making sense. But if we can add more telemetry until the cows come home, we don't really get any closer to a meaningful presentation of what's actually happening. Let's imagine you're on call and you get paged, and the alert opens up to a chart that is showing a spike in CPU utilization. You're left with the question, what's happened? 10 years ago, this chart may have been enough to go on, but now there's so many variables that could be involved. Investigating ends up taking a ton of valuable time and stretching out the actual impact. The problem is the chart is only showing you the symptom, but it leaves out the context for what's different across your system. So how do we make progress on this issue, right? We have a CPU spike. And so I'm going to share like a secret that maybe isn't revealed too often. Finding root cause does not get any easier the more you know about a system. It's really about how skilled you are with correlating disparate telemetry, or to say it differently, how experienced you are with your observability tools. When you're an observability expert, you can recognize a pattern you've seen before, and you know which tool to drill into to get the needed information to solve the problem. But more likely, you have to dig through dashboards and grep through logs and stitch together clues. And you end up having to wake up somebody else if you get too far into some part of the system that you're just not familiar with. But notice, this option is really only works when on problems that fit a known pattern that you've already addressed in the past. A lot of times the remediation path is just not that clearly defined. And I'm kind of embarrassed to say that I've spent many late nights and weekends like tuning thresholds, writing remediation scripts, thinking maybe if I just build one more dashboard to catch this failure next time, it'll help. And I kind of learned the hard way, like I'm sure a lot of you did, that we can't even begin to predict every single failure mode nowadays. So ideally, what should the dashboard do, right? It should take your existing metrics and dashboards and charts and things that you look at every day anyway, and then turn them into a bridge into the rest of your system. So from any chart, you should be able to drill into changes related to like the CPU spike. And the tool itself should show me and kind of what related anomalies correlate to the CPU spike across meaningful dimensions that are important in that moment. This makes sense, right? Like you shouldn't have to switch between multiple interfaces to see what's happening. Okay, so let's walk through what it takes to build something like this for yourself. And then we'll dig into what Ben Siegelman calls the anatomy of observability. Okay, so we've established like you can't have observability without the raw telemetry. And as far as gathering that telemetry, historically engineering orgs have had about two options. Number one, hire more engineers, mount a massive effort and start gathering high quality telemetry, or pay a vendor to do it. Most of these options are both of these options are pretty expensive. But now there's an alternative that brings together the best of both worlds, and that's open telemetry. So Open Telemetry project is also known as OTel. It aims to make high quality telemetry a built-in feature of cloud native software. All major cloud vendors have pledged their support for OTel, including AWS and Azure and GCP. And most vendors that offer some sort of observability solution are on board, including my company, Lightstep. Lightstep is one of the founding members. So there are a ton of reasons why OTel is the bee's knees. It's now possible to get high quality vendor neutral telemetry without code changes. In this way, OTel is disrupting the idea of needing proprietary agents to gain access to integrations. As a result, you really don't need to buy observability from a vendor just to gain access to their suite of data integrations. Any OTel compliant observability provider will have access to high quality telemetry across the stack, and all with zero vendor lock-in. So if layer one is about gaining access to the high quality telemetry, then layer two is about where you're sending it, as well as how and for how long you store it. When it comes to observability, data stores, we find ourselves with a choice. Fundamentally, if we want to handle high throughput data or high fidelity measurements like per container CPU metrics, we have to record statistics into a time series database. Otherwise, we waste too much time, too much on the transfer and storage of individual events. If someone says you can sample production data, take it with a grain of salt, because for low frequency data hidden within high frequency data, you can miss it altogether. That's why a dedicated time series database, a data store that's designed specifically for the storage, indexing, and querying of time series statistics is needed. Now, if we want to handle high cardinality data, for example, like per customer tags or unique IDs for ephemeral things, a time series database is a total expensive disaster. With high tag cardinality comes an explosion of unique time series, and with it an explosion of cost. And so there must be a transaction database as well. Traditionally, this was a logging database, although we recommend building around a distributed tracing native transaction DB, since this can handle both logs and traces. So say you found the best of breed transaction and time series databases. This is necessary, but it's still not sufficient. Remember when I said resources and transactions are related? To make the actual observability part, the data layer needs to be integrated and cross-referenced, preferably as deeply as your tag and attribute cardinality goes. At the end of the day, telemetry, no matter if you're looking at it or if you're storing it, it is not intrinsically valuable. Let me say that again. Telemetry and telemetry storage is not intrinsically valuable. It's only the workflows and the applications that you build on top of it that can be valuable. So yeah, in like the conventional presentation of observability as metrics and traces and logs, we don't really even talk about what problem we're solving, much less how we're solving it. So there's really only two problems worth solving with observability. Number one, you got to understand the health of your system. Connecting the well-being of a Substack subsystem back to the goals of the overarching application and the business through thoughtful, purposeful monitoring. This means representing your business goals alongside your dashboards and your alerts, and making sure that your SLOs are centered on your customer experience. And then the second problem is understanding change. So this is so you can accelerate your planned changes while mitigating the effects of unplanned changes. So if that makes sense. Now let's tie all these concepts together, because I know we kind of like walk through a lot into some kind of key takeaways. All right. So number one, some of us thought monitoring was dead, but it's not. Monitoring isn't going away, because understanding the health of your system is always going to be important. But monitoring needs to evolve to connect the needs of your business to the behavior of the application as directly as possible. If you've refocused your SLIs, SLOs to your customers, you'll see growth across your business, driving revenue, enhancing customer experience. Now, the second value we talked about was having intelligence around change. Observability is most accessible and actionable and broadly applicable when it's anchored around changes. Either the planned changes of like software deployments or unplanned changes of incident response. You'll start to see fewer customer-facing outages because you'll be able to connect the cause and effect more quickly. Observability can also close the loop for CI/CD, and it can give you more confidence about your local and global health of your deployments. Because these are they're endless potential failure modes. So when monitoring fails, observability needs to deliver by making it easy to see what's different across your service boundaries. So finally, it has to be accessible to as many people as possible. You don't want the system to be require an expert to look at it. Just side note, this is a screenshot of Lightstep's observability platform, just so you could see an example of what it looks like. So other takeaways: start adopting open telemetry. Try to avoid getting tied down with proprietary agents and dependencies if you don't have to. Open telemetry, auto instruments, dozens of popular libraries and frameworks. So now you can get started without writing any code. We actually have some really good resources to get you up and running on your own. And once you get set up, you can easily repoint your config to any of the major providers, because they're all on the same standard. As a side note, for standards, having standards in general is a huge impact when it's aligned to best practices. Imagine every engineer you add to your team already knows how to work with your system for gathering telemetry. It would improve developer onboarding and help get projects off the ground a lot faster. Now, in terms of storage, beware of any solution that claims to provide observability with only event data or only time series metrics. You need both at scale. So it's important to consider this before your user base grows. And then knowing that sampling hides low frequency data that can be like a canary in a coal mine about issues before they get widespread and affect all of your customers. And then probably the most importantly, in order for your storage to be effective, it really needs to allow you to ask questions about what's changed. One bonus tip, because this is something I've seen across all the tools, as you scale, telemetry gets more expensive and it happens sooner than you expect. So look for solutions that have some kind of variable telemetry cost controls. That's pretty much all I wanted to cover today. Does anyone have any questions about what we covered or anything like that?
Yeah, thank you, Carl. That was an awesome presentation. Yeah, so like Carl said, at this time, we're going to move into our Q&A session. So there are a few questions in the queue, and we'll answer as many questions as we have time for. And just a reminder, this is being recorded and you will receive a copy of this later today or early tomorrow. So one very important question that came in, Carl, is what animal had had to be hunt down for you to get the coloration in your beard?
This is zebra, so like it's directly sourced zebra extract. So I don't know, like I think yeah, zebra is probably the best answer because the rest of this is just au naturel.
Absolutely. Thank you for
But
answering.
peanut butter and stuff is usually what it uses. Yeah. Thanks for the question.
Important things. Okay, now on a serious note. So you talked about broken cloud dependency. Can you be a little more specific on that? If I am using real-time emulation and monitoring of all layers 3 through 7 IP flows, then will I not be able to detect this broken entity?
Well, yeah, detecting it is good. So however you can get the data in, whether it's through metrics or whether your components support something like OpenTelemetry, where they're able to send spans into a collector to provide that context across the transaction, then that's ideal. So but yeah, so I'm trying to think of what else we could talk about on the broken cloud dependencies side.
We can also get back
Yeah, I'll
to
get back to you on that. I guess I got to think about that a bit more.
yeah, no worries. So next question, how are you pulling in change data? Is it by CMDB?
So change data is interpreted through a few different ways, but it's mainly through actual changes in the metrics metadata and in the span attributes. And so the tags and attributes and baggage that's being sent into the system, that's what's noted. So you can send events and so like for example on Lightstep we could send in markers or you could send in like a reported deployment tag. So then you don't have to remember, oh, we have to integrate an additional event in with the system. It just organically marks on the charts that there was a deployment change. And so I guess the best way, in our opinion, would be to build something or use something that's dynamically identifying changes organically. Otherwise, you're gonna be on the hook to say, oh, deployment was changed. We replaced this library. We upgraded. We patched the OS. I don't know, something like that.
Awesome. Okay, next question. How does Lightstep detect what has been changed?
That's a great question. I think just in terms of like what I was saying at the last answer, just it's looking at the metadata and identifying what's different. And so maybe we'll gather the tags and metrics that are correlated with, say, the anomaly, say your spike in utilization versus the baseline. And so we'll be comparing the differences between those two time periods. So before the issue occurred and after, and then while the issue is happening. And so that way you can see what percentage of transactions that were in error or exceeding thresholds contained different tags or attributes. Like they all went through this particular broker or this particular host, or they all had this particular customer's tag on it, so you would know it's something related to the customer from that point on.
Awesome. Can you explain the difference between monitoring and observability, and isn't that the same thing?
Yeah, that's a good question. Monitoring is like, so let's see. Yeah, it's a common question. All right, so monitoring, you know where to start. Monitoring is about things that you know how to fix. You're like, oh, okay, I want to be alerted if a server goes down. I want to be alerted if something is wrong. I want to track CPU. These are things that you know that you want to look at. And these are things you typically throw up on a dashboard. And then so then observability is kind of like more about the things you don't know about. You don't know where to start. You don't understand the system enough, or you don't have observability is kind of like picks up where monitoring left off, where you can where you don't have to set up a monitor for every single thing. You can always just jump into your observability solution and just go and look and see what's new, what's different, where this transaction is going to, things like that.
Awesome. Next question, how much of coding is needed to instrument applications?
Let's see, for open telemetry, so like, let's see, I think slide right before this. So in terms, if you're using one of these languages, there's support, you won't have to do much else. But then also automatic instrumentation is what you're looking for. You want to use an agent or something that's going to automatically add spans for all the portions of your application. So this list is growing, but what you can do is there's if you go and check out the site hotel at lightstep.com, there's some guides there. And then Lightstep published a launcher. You could use this with your own stuff, but it simplifies it a lot. And so it'll help where you just add a few lines for your API key or your destination, and it'll get you going. And the only time you really need manual instrumentation is if you discover that the auto instrumentation libraries haven't really covered much. So that would be occurring a lot in maybe front end, like JavaScript side. PHP is one, for example, that seems to end up being a lot of kind of manual start and finish. But it's not that hard. I think you'll see examples if you go into those docs.
Awesome. We have time for one more question. And just a reminder, if you did ask a question and it did not get answered, we will get back to you after this session. Okay, so last question. How does Lightstep keep costs down if you are not sampling and collecting and analyzing 100% of telemetry data, including high cardinality customer data, for instance?
Yeah, okay, that's a good question. Lightstep has a slightly different architecture than other solutions, where you have we run what's called a satellite that's local to your servers, and so you could use that to process and store in memory your most recent transactions, all your spans. So you can and then query that from the UI. So you have a 16 gig memory buffer per satellite, and you could use that to query and assemble traces from 100% of your transactions. And so depending on your load, you could scale that up to increase the amount of history that you have that 100% window for. So that's one solution, and there's also a Lightstep hosted version of the same thing that's coming out this month. But so you do have in the moment for like the most recent transactions, you have 100%, and then any query that you execute that gets stored on Lightstep SaaS, and in like average about a month, you could recall it and bring that back up.
Awesome. All right, well, that's all the time we have for today. I want to thank Carl for presenting and all of you for joining us. And another reminder, you will receive a copy of this presentation. Other than that, hope you have a great rest of your day. And if you'd like any more information on today's topic, please visit us at lightstep.com.
Thank you all.